Hello, and welcome back to Math 8. This is a video over Unit 2, Section 1, and what we're going to be doing is we're going to be constructing linear functions, okay? And our objectives today, we want to analyze linear functions to find the rate of change in initial value. We want to interpret the rate of change in initial value of a linear function in terms of a situation it models, okay? So let's first talk about initial value. So the initial value is the starting value of a function when the input is 0. So let's put that into a little bit of layman's terms. It is the y value when x equals 0, okay? And so we have this first initial problem, okay, where it says Aiko is emptying her 1,600-gallon pool at a rate of 210 gallons an hour. What is the initial value? So let's think about this for a second, okay? If you're draining a pool, all right, and so let's do, x is time. Your y value is going to be gallons of water, of H2O, okay? And at time 0, before Aiko starts to pull it right, gallons an hour, so time is in hours, okay? So what we can do is we can sit here and we can say, all right, well, what is the initial value in the situation? So at time 0 hours, how many gallons of water are in the pool? And that answer would be 1,600, okay? And I'm just drawing the graph to have you guys see how I'm thinking about this and how you could also think about this. You do not have to think about it this way if you don't want to. You could think about it another way. And what would happen is that the amount would drop over time, okay? So my initial value, and let's write this out, my initial value is equal to 1,600 gallons, okay? Now, I know that because at t equals 0, time, or x equals 0, okay, my y value is 1,600, okay? And that's how we do that. All right, let's take a look over here on this one. It says, okay, Namazi started her savings plan a few months ago and created a table to monitor her progress. What does the initial value represent? So when the time is 0, how much money had been saved, okay? So what does the initial value represent? And that represents $55, okay? That has been saved already. Has been saved, okay? What is the input of the initial value? So the input, what is the x value of the initial value? X is equal to 0. What is the output of the initial value? Remember, output means y. Y is equal to 55. Okay, so what we can kind of gather from this is that initially, $55 was already saved. Okay? All right, so that's how we deal with initial value. And those are the things that we talk about when we talk about the initial value. So let's talk about rate of change. Now, rate of change is the slope, okay? So if you've heard the word slope, rate of change means the exact same thing. So now here they talk about finding the rate of change. But let's do this. The rate of change, okay, rate of change, which is your slope, okay, is we use the variable m, okay? And what we do is we take the change in y divided by the change in X. Okay, now remember how we do that. What I want to do is to go through and determine what is my change in X. Okay, so we'll start with that. It means we're adding 1 to both sides to get the next consecutive value. Okay, now my amount saved here, we're going to change that or see what the difference is here. Now 55 to 67, remember you can just do 67 minus 55, and that's going to give us 12. Okay, so $12. To get from 67 to 79, same thing, take 79 minus 67, and that's going to give me $12. Okay, let's take 91 minus 79, and that's going to give me $12. Okay, so what we're doing is we're adding $12 the whole time. Now, all right, so my change in y, so my slope m, let's write this out, is equal to the change in y, which is $12. So $12 per 1 month. Okay, so 1 month. So what we need to say, the rate of change, we need to start thinking about the labels on our graph to give us a situation where we can find the rate of change. So what we can say is that they are saving $12 per month. Okay, and that is what our rate of change is. Okay, and that's that. Okay, let's take a look at the next page. Okay, so sometimes you aren't given the initial values. Sometimes you're given like pieces of information, and what you're being asked to do is to calculate the initial value. So let's take a look at this. So we're going to look at a table and a graph, okay, or a table right now. Okay, so Gregor adds the same amount of money to keep his piggy bank, each month. The table below shows the total amount of money in his bank. So the amount of money is here, okay, here, and then in his bank at the end of the months 3, 4, and 5. Find the amount of money in the bank when he started saving. So what we want to do is we want to think about the rate of change, okay? And let's do this. I'm going to do that over here. So I'm going to add, to get from 1 month to the next, we are adding a month. To get from one column to the next, 41 to 53, and then 53 to 65 is we're going to add 12. Okay, so what we've got, our rate of change is $12 per month. Okay, now what we want to do is we want to find our initial value. So what we're going to do is we're going to now then subtract. Okay, so to get from one side to the next, we wanted to subtract minus 12, minus 12, minus 12. So to get what's going to go in this box, I want to take this number and subtract my rate of change, which is $12 per 1 month. So if I take 41 minus 12, which is going to give me 29, okay, if I subtract 12 again from that, all right, that's going to end up giving me 17. And if we subtract 12 from that, that's going to end up giving me us 5. So the initial value, what we're looking for when the month is 0, okay, is going to be the amount of $5 has been saved. Okay, so my initial value, and that's this number here, is $5, okay, and that's that. All right, now we can do the same kind of thing for a graph, okay? And so an arcade gives a certain number of free tokens to the first-time customers. The graph shows the number of tokens a customer received for $3, $4, $5, and $6. Assuming that the relationship is linear, find the number of tokens a customer would receive per dollar. So what this says is, as we look over here, okay, what this means is that for 6 tokens, okay, for $6 spent, that means you get 44 tokens. If you spend $5, you're going to get 38 tokens. $4, you get 32, and $3, you get 26. So what we want to figure out, and here's what I'm going to do. I'm just going to write X and Y, okay? And let's write these numbers down. We got 3, 4, 5, and 6, okay? So to get these values, so 26, 32, let's put them all down first, all right? You know, what I want to do is figure out what are we increasing by. As x goes up by 1, okay, what are my y values doing? So 26 to 32 means that we are adding 6. 32 to 38 means we're adding 6. 38 to 44 means we're adding 6. Okay, so our rate of change, our slope m, is equal to 6 tokens per dollar. Okay, now what I want to do is to now go backwards, or that's how we figure that out. Now let's think about this. You know, we have a stair step here. Means that we're adding 6, okay, for every dollar. Adding 6 tokens for every dollar. Adding 6 tokens for every dollar. So this is plus 6 on each of these, and then plus $1, okay? And so I get those numbers just by, you know, you can kind of think of the stair-step model, or you can think about the table of values. Okay, so now let's go backwards, all right? So if I have 2, all right, and I subtract 6, it's going to give me 20, all right? So 2 comma 20, all right, 2 comma 20. Let's subtract 6 again from that, and that's going to give me 1 comma 14, okay? And then let's subtract 6 away from that, and that's going to give me 0, 8. So it didn't ask me for the initial value, but I'm just following this pattern. So my rate of change, remember, is going to be $6 per 6 tokens. Sorry, 6 tokens per $1, okay? And then let's talk about our initial value. So initial value is 8 tokens, and that's for the first-time customers. Okay, first-time customers. All right, and that's that. All right, now let's go ahead and compare a couple linear relationships. Okay, it says compare the different representations of the data below. Do they show the same information? So here's what I want to do. I can figure this out by finding my initial, my rate of change and my initial value. Okay, so my rate of change, okay, for this first one means we're going to add 1 to my x values, and then we were going to add 2.5, okay, to get the other y values. All right, so, and this is add 2.5. So what this means, you know, if I wanted to talk about my rate of change, all right, this would be 2.5 pounds, so 2.5 pounds per week. Okay, so 2.5 divided by 1. All right, so that's my rate of change. Now, what I want to do is to go backwards. All right, and so let's do this real quick to see what we get for our initial value. And I'm going to do this. I'm going to do x and y. I'm going to do 0, 1, 2, 3, and 4. Now, 4 we had 16. Now, I'm going to subtract 2.5 from each of these, all right, just to see what happens. Okay, so 16 minus 2.5 is going to give me 13.5. So let me come in here. All right, I've got 13.5. Let's subtract 2.5 from that. That's going to give me 11. Minus 2.5 from that, and that's going to give me 8.5. Okay, subtract 2. So 8.5 minus 2.5 is going to give me 6. Okay, so my rate of change is 2.5 pounds, and my initial value is 6. All right, so my initial value is equal to 6. All right, so here is what we've got. Now, if we have the same rate of change and initial value, then we've got a similar problem. So same thing. Okay, x is weeks, y is weight. All right, now my initial value. All right, let's just write this out. I've got an x column and a y column. When x is 0, y is 5.7. When x is 1, my y value is 8.2. When x is 2, my y value is 10.7. So here's what I've got. All right, I'm going to do 10.7 minus 8.2. Sorry, 10.7 minus 8.2. And that's going to give me 2.5. All right, so to get me that, that's plus 2.5. All right, 8.2 minus 5.7 is also going to give me 2.5. 8.2 minus 5.7 is 2.5. Okay, so here's what we got. Our rate of change is the same, equals 2.5 pounds per week. Okay, but my initial value is equal to 5.7. So what I know about these two scenarios, comparing these linear relationships, they have similar information. Okay, the rate of changes are the same, but the initial values are different. Okay, so what we can see is that as the number of weeks go up, the pounds increase. Okay, same thing here. They increase by the same rate, 2.5 pounds per week, but they start off at different rates, or at different values. Okay, this one starts off at 6 pounds at 0 weeks, and then this starts off at 5.7 pounds. Okay, so that's what I got. And let's go ahead and get started on the assignment and quiz, and we'll see you soon. Thanks a lot. Bye.